Imagine trying to update one tiny fact in a massive language model, and suddenly, poof, it forgets everything else you taught it. Oops, that's the problem AlphaEdit tackles, and it does it with just one magical line of code. Instead of clumsily rewriting the model's memory, AlphaEdit whispers its edits into the Null-Space, a secret mathematical dimension where preserved knowledge stays untouched. It's like editing a document with invisible ink that only changes the right lines. In today's deep dive, we'll explore this ICLR 2025 Outstanding Paper Award winner, unpacking how this elegant tweak revolutionizes model editing, boosts performance by over 36%, and keeps your LLM sharp without memory loss. Let's roll!
Let's start with the problem. LLMs are incredible at recalling information from their training data, but they're not perfect. They hallucinate, spitting out outdated or made-up facts. To fix this, researchers have turned to model editing, updating specific knowledge inside the model without retraining everything from scratch. Most editing methods follow a simple two-step process. First, they pinpoint the parameters tied to a specific fact. Then, they tweak those parameters slightly, what we call a perturbation. Sounds straightforward, right? But here's the catch. Changing one thing can accidentally mess up other knowledge the model already has. It's like editing one sentence in a book and accidentally altering the meaning of the whole paragraph. This becomes a huge issue when you're doing multiple edits. Each one can ripple through the model, distorting unrelated knowledge. That's the challenge AlphaEdit tackles. The key idea? Instead of applying edits directly, AlphaEdit projects them into a special null space, a direction in the model's parameters that doesn't interfere with preserved knowledge. Think of it like a surgical tool that only cuts where it won't cause collateral damage. And the best part? It's just one extra line of code. In tests, AlphaEdit boosts editing accuracy across models like Llama, GPT-2, and GPT-J, without breaking what the model already knows. So why do current methods struggle? Let's dig deeper. When you edit a model by directly tweaking its parameters, you're trying to correct one piece of knowledge, but you often end up shifting its entire internal state. Check out Figure 1 here. In Part B, you'll see how hidden representations the model's thoughts warp after editing. That shift isn't just learning, it's forgetting. Part C shows the fallout. The model starts looping outputs like, the largest ocean is. A classic sign of knowledge interference. AlphaEdit flips the script. Part D shows its trick. Instead of optimizing directly, it first projects the edit into the null space of preserved knowledge. This ensures the update doesn't disturb existing facts. The result? Part E reveals almost no change in hidden representations post-edit. The model learns something new without unlearning the old. And the payoff is clear in Figure 2. AlphaEdit outperforms methods like ROAM and MEMIT across benchmarks, all with that single line of projection code. Now let's get technical. How does a language model store and retrieve knowledge in the first place? When predicting the next token, the model combines two voices, the attention block, tracking context, and the feed-forward network, pushing the sentence forward. Together, they shape the hidden representation of each token. Here's the cool part. The feed-forward network acts like a memory lookup. It uses keys and values. For example, mapping, the Olympic Games was held in to Paris. This structure inspires model editing. We inject small perturbations to update these key value pairs. But we don't want edits to corrupt old entries, so we frame this as an optimization problem. Find the smallest weight change that achieves the update. Then, we add a constraint. Preserve existing key value pairs. This leads to a balancing act. New knowledge versus old. If we know enough about the model's internals, there's even a closed-form solution. That last equation on the page. No iterative search needed. Just a clean matrix inversion to compute the optimal update. Here's where the magic happens. AlphaEdit's null space trick. The goal? Edit the model without disrupting preserved knowledge. The idea is simple but powerful. When you tweak the model, project the update into a subspace that's invisible to old knowledge. Equation 7 confirms it. After projection, the model still answers preserved queries correctly. But how do we build this projection? The preserved knowledge matrix is massive. Think 100K dimensions. Directly computing its null space would be a nightmare. Instead, AlphaEdit uses a clever workaround. It computes the null space of a smaller matrix, equation 8, using singular value decomposition, or SVD, to identify safe directions. Equation 9 then defines the projection matrix using those directions. Finally, equation 10 shows the result. Apply this projection, and your update won't harm old knowledge. It's like performing brain surgery with a precision laser, leaving everything else intact. Let's zoom in on how AlphaEdit simplifies model editing. Normally, you're juggling two goals: learning new facts and preserving old ones. That's why methods like MEMIT bundle both into one messy optimization. AlphaEdit asks, what if we handled preservation first? Project the edit into the null space up front, and you can ignore preservation during optimization. Equation 11 captures this. Just focus on the new knowledge and regularize for stability. But there's more. Sequential edits can interfere with each other. So AlphaEdit adds another term, equation 12, to protect prior edits. Then, it computes a residual, the gap between current and desired outputs, and solves a linear system for the optimal update, equation 14. Compare this to MEMIT's solution, equation 15. It's more complex because it's still wrestling with preservation. AlphaEdit? It's already handled. That's why it's so lightweight. Just one line of code to plug into existing methods. Time for results. Does AlphaEdit actually work? Spoiler, yes. Check out the giant table here. It compares editing performance across Llama 3, GPT-J, and GPT-2XL, tested on datasets like Counterfact and ZSRE. 5 metrics tell the full story. Effectiveness. Did the edit stick? Generalization. Does it apply broadly? Specificity. Is it precise? Fluency. Does the output sound natural? Consistency. Does old knowledge stay intact? AlphaEdit dominates. It's bolded nearly everywhere, especially in effectiveness, without sacrificing fluency or consistency. The section also poses 4 key questions. Does AlphaEdit outperform other methods? Does it prevent forgetting? Can it preserve general capabilities? Can existing methods improve with just one-line projection? That last one's huge. You don't need to ditch your current method, just add AlphaEdit's projection. Now let's talk general capabilities. After thousands of edits, does the model still work? Look at figure 4. 6 line plots track performance on tasks like sentiment analysis, SST, and natural language inference, NLI. As edits pile up to 3,000 of them, the y-axis shows F1 scores. A flat line means no collateral damage. AlphaEdit's red line? Almost flat. Others like MEMIT or Prune, they nosedive after just a few hundred edits. That's the difference. AlphaEdit preserves the model's core abilities. The numbers back this up. On Llama 3, AlphaEdit boosts efficacy and generalization by over 30% compared to the next best method. Even fluency and coherence improve. Subtle but critical for real-world use. And it's not cherry-picking. They test on Glue, a broad benchmark, to confirm the gains are real. Here's a deeper issue: hidden representation drift. Edits shouldn't just preserve outputs, they should keep the model's thinking stable. To test this, the authors measured hidden states for 1,000 prompts, before and after 2,000 edits. Figure 5 shows the results. With MEMIT or REC, the red, pre-edit, and blue, post-edit, clouds barely overlap, the model's internal state is shifting. AlphaEdit? The clouds are nearly identical. The model thinks the same way, even after edits. They double-check with tasks like SST and MMLU. AlphaEdit holds up. Other methods degrade fast. The takeaway? AlphaEdit isn't just accurate, it's stable. What if we took existing methods and just added AlphaEdit's projection? Figures 6 and 7 show the answer. Figure 6 compares MEMIT, Prune, and REC before, yellow bars, and after, blue bars, adding the projection. Every metric jumps: effectiveness, generalization, specificity. Figure 7 breaks it down further. The left panel shows accuracy gains across knowledge types, born in, produced by. The right panel shows improvements on general tasks like SST and COLA. Every dot shifts up. This is the power of AlphaEdit. It's plug and play. Drop it into any method, and performance improves. No overhaul needed. To wrap up, let's place AlphaEdit in context. Model editing research splits into 2 camps. First, parameter-modifying methods, like MEMIT or ROAM. They tweak weights directly. Second, parameter-preserving methods. They use side modules to inject knowledge. AlphaEdit works with both. Just add the projection. Limitations? It's only been tested on LLMs, not multimodal models or long reasoning chains, but its stability makes it promising for domains like math or science, where preserving core logic is key. The conclusion is simple. AlphaEdit is a null-space projection that makes edits precise and non-destructive. One line of code boosts performance by 36% on average. It's effective, easy, and ready to use. Thanks for joining us today. Happy exploring!